Welcome to my science class. In this class, we'll solve sums from class 10 NCERT textbook. The sum says a copper wire has a diameter 0.5 mm and resistivity of 1.6 into 10 to the power of minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohms? How much does the resistance change if the diameter is doubled? So there are two parts in the question. The first thing, they are given as a wire, the diameter of the wire and the resistivity they are given, and the resistance what we have to achieve is 10 ohms. And they are asking us to find out the length of the wire required to get the resistance of 10 ohms. The first part. Part 2 says how much does the resistance change if the diameter is doubled. So first we will answer the part 1. We'll first make a list of the data given. They were given us the diameter is equal to 0.5 millimeters. Then they are given the resistivity. That is rho. It's equal to 1.6 into 10 to the power of minus 8 ohm meters. Then they are given as the required resistance. The resistance R equal to 10 ohms. Now we have to find out the length of the wire. Length of wire. It is L. We have to find out. So now the formula what is known to us is R equal to rho L by A. In this formula, we know the value of R, 10 it is. Value of rho we know, resistivity. We have to find out L, but we don't know the value of A, that is area of cross section of the wire. So first we have to find out the area of cross section by using this diameter. So to find the area of cross section, we require radius. So radius equal to radius R equal to 0.5 by 2 millimeters. That's equal to 0.25 millimeters. We have to convert it into standard units, that is, we have to convert it into meters. So we know that 1000 millimeters is equal to 1 meter. So we will divide it with 1000. So 0.25 divided by 1000 meters. So it will become 0.00025 meters. We will write in the standard form. I am shifting the point after 2 there. So it will become 2.5 into 10 to the power of minus 4, because I have shifted the point 4 places to the right side. So you will get a power minus 4 meters. So we have found the radius to be 2.5 into 10 to the power of minus 4 meters. Now we will calculate the area of cross section. Next we will calculate the area of cross section of the wire. Area of cross section. Of the wire. A equal to, the formula to find the area of cross section is pi r square. Pi r square. That's equal to 22/7 into r square. R is what? 2.5 into 10 to the power of minus 4 into 2.5 into 10 to the power of minus 4 will be equal to, so 22 into 2.5 into 2.5, we will get 137.5 into 10 to the power of, now we have to add the powers now, these two powers. So 10 to the power of minus 8 divided by 7. So when we divide it with 7, we will get 19.64 into 10 to the power of minus 8 meters square. This is the area of cross section. Now we will use the formula. Actually, we have to find the length of the wire. So the formula is R equal to rho L by A. So here we will calculate the value of L. So first we'll cross multiply it. So rho L is equal to R into A. So L equal to R into A by rho. So L equal to, what is R? 10. R is 10 ohms into A is 19.64 into 10 to the power of minus 8. Rho is nothing but resistance. That is 1.6 into 10 to the power of minus 8. So here this will get cut, 10 to the power minus 8 and 10 to the power minus 8 cut. So now if you multiply this, you will get L equal to 196.4 divided by 1.6. So that will be equal to L equal to, so I am going to shift the point one place to the right side, then also it will get shifted. So 1964 by 16 meters. So if we divide, we will get L equal to 122.75 meters. Therefore, the length of the wire is wire is 122.75 meters. You have found the length of the wire. Next we will see the change in resistance when the diameter is doubled. Now the second part of the question is how much does the resistance change when the diameter is doubled? So there are two cases here. In the first case, that is case 1. Case 1. In the case 1, original resistance. Original resistance. Let the original resistance be equal to R. R1. Then resistivity will not change. Resistivity is equal to rho. Let it be rho. Resistivity is rho. Then length of the wire is equal to L. Now the diameter of the wire is equal to D. Now we will calculate the area of cross section. So when the diameter is D, radius will be equal to D by 2. Okay. Then area of cross section. Area of cross section A is equal to pi r square. Pi r square, that's equal to pi into r square means d by 2 is r, so d by 2 into d by 2. That will be equal to pi d square by 4. Pi d square by 4. This is the area of cross section. Now, so R1, that is the original resistance. R1 equal to rho L by A means pi d square by 4. So R1 equal to rho L into 4 by pi d square. R1, that is the original resistance R1 is equal to 4 rho L by pi d square. So we will label it as equation 1. This is the original resistance. Now coming to case 2. So here new resistance. Is R2. Here resistivity is same. Resistivity is same. Length is same. Length of wire is same. It is L. Now diameter is doubled. Diameter in case 1 it was D. Diameter is doubled. That is 2D. Now we'll find the radius. Radius R equal to 2D by 2. That's equal to D. Next we'll find the area of cross section. Area of cross section. A equal to pi R square. That's equal to pi into D into D. That's equal to pi D square. This is the area of cross section in case 2 when the diameter is doubled. Now we'll find the new resistance. It is R1, R2. The new resistance R2 is equal to rho L by A, pi D square. Pi D square. So this is statement number 2. So from 1 and 2, R1 by R2 is equal to 4 rho L by pi D square divided by rho L by pi D square. So R1 by R2 equal to 4 rho L by pi D square into pi D square by rho L. R1 by R2 is equal to 4 rho L pi D square divided by pi D square rho L. So here this will get cut there. So R1 by R2 is equal to 4 by 1. So we got R1 by R2 is equal to 4 by 1. So when you cross multiply, 4R2 is equal to R1. So R2 equal to R1 by 4. You can see here the new resistance has become 1/4 of the previous resistance. Therefore, the resistance has become 1/4 when the diameter is doubled. When the diameter is doubled. Please like, share and subscribe. Thank you.